Okay, we're now in the next video, that is video 3 and solution to question. Okay, wait to question 5. Please, in addition to question 5, please. Question 5 is D. We're now video 3, video 2 of solution. We're going to be solving question 6 to question 10 in this video. Question 6 to question 10. Question 6 says, write the expression minus x to the power of 3. I'm going to try my best to talk slowly now because I know in the other video I was speaking too fast. Okay, we said write the expression minus x power of 3 minus x plus 5 in standard form and identify the polynomial by degree and number of terms. We have this in the last videos, like the previous test review videos. I hope you watched it before going for the exam. Okay, to write it in standard form is already in the descending powers of x. So the only thing we need to do is to multiply by minus 1. So we have minus x power of 3 minus x plus 5. If you multiply by minus 1, we have x to the power of 3 plus x minus 5. Let us already make the question easy. That is, all the options here have x to the power of 3 plus x minus 5. So the only job you have in this question is to determine its degree, determine the number of terms, and number of terms are there. So let's begin. The degree of this, if you have to look at the first term, that is, this is the standard form. The first term will have the greatest power. But if it's not in standard form, then you have to look for the greatest term. That is the term with the greatest power. In this case, the greatest power here is 3. So this is going to be a cubic function. Or rather, a cubic polynomial in this case, a cubic polynomial. So now let's look at it, the number of terms. There's one term here, there's 2 terms here, or there's one term here, there's one term here, there's one term here. Let's talk 3 terms. So we have 3 terms. So this is a cubic polynomial, or a cubic trinomial. Since it has 3 terms, it's 3 terms. If you now look at it in terms of degree, the degree is 3. So this is the third degree or degree of 3. Now let's look at the inside the option. Option A says degree of 3, correct. Cubic monomial, wrong. This is a trinomial. Monomial means it has 1 term. That's you're supposed to look at in depth into this question. Don't just pick it because you're seeing cubic. You now come and pick cubic monomial. No, it's a trinomial. Option B now says degree of 3, correct. Cubic polynomial, also correct. It could be a cubic trinomial, cubic polynomial. It's just correct. And trinomial, that's absolutely correct. Let's look at option C. Degree of 4, that is wrong. It's not a degree of 4. Quartic polynomial, no. And trinomial, that's a trinomial, but the first 2 are wrong. Option D now says degree of 4, which is also wrong. Quartic polynomial, also wrong. Quadratic, also wrong. So option B is going to be our correct option. Let's quickly go on to question 7, which is the second question in this video. Question 7. Classify the polynomial 2x plus 3y plus 5 by degree and number of terms. 2x plus 3y plus 5. Now, I'm not sure if this is going to confuse a lot of people because of most of the times we'll be solving it in terms of x. So some people will just say, okay, since it's only in terms of x, then you now want to omit y. If you have something like 2xy, 2xy, because this is already is one variable, this and that variable. By the time you multiply them together, it will have a degree of 2, so this will be second degree. In this case now, the x and y are not going to multiply each other, so you don't even get confused. So you have this here has a degree of 1, this is x power 1, here has a degree of 1 also, that is y power 1, and here has a degree of 0. It's not multiplied by any variable, so it has a degree of 0. So the greatest degree here is 1, in both cases 1. So it's going to have a degree of 1. The second part is number of terms. There's one term here, 2x, there's another term here, 3y, and there's a third term here, 5. So it has 1, 2, and 3. That's 3 terms. So this has a degree of 1 and trinomial, and the trinomial contains 3 terms. So let's look at our options. Option A to C has degree 1, 2, sorry, it has degree 2, 2, and 3. So A to C is wrong. But if you look at option D now, you have degree of 1, which is correct. You have linear, which is also correct. And you have a trinomial, which is also correct, because it has 3 terms. So this is going to be the correct option, option D. Question 8 now says we should solve the equation 2x squared minus 5bx is equal to 3b squared. Just like I said in the test reviews, there's a reason to solve this though, but in case you don't know, you have forgotten how to solve entirely, you multiply those two solutions that they gave you. Those solutions, by the time you multiply them, you should get your constant term. By the time you add them together, the negative of that will give you your x coefficient. Now let us solve it for people that do want to know the full solution. You have 2x squared. You have to write it standard form. 2x squared minus 5bx minus 3b squared is equal to 0. First, right, you have to divide it by 2. Sorry. You have x squared minus 5 over 2 bx minus 3 over 2 b squared. Okay, I'm going to use the Almighty formula. Yeah, I'll use the Almighty formula for ease, my sake. We have x equal to minus b plus minus the square root of b squared minus 4ac divided by 2a. For me, during the exams, I'm always, even though the Almighty formula is the shorter method, but I'm always afraid that what if I come and get a polynomial that is here, that I'm not sure of how to break it down into two products. That's why I normally use the complete square method, but they're just the same. But in this case, I'm not afraid of that because I've noticed that here and here we have something in common. Okay, but let us solve. We have minus b. Oh, let me just use b because b is already here. Let me use capital B, capital B, capital A and C, and capital A. Let's to avoid confusing there. So the value of b here is the coefficient of x. So capital B, or let me start from capital A. Capital A is going to equal to 1. Capital B is going to equal to minus 5 over 2. And capital 2b. And capital C is going to equal to minus 3 over 2b squared. So we put all this back into this Almighty formula. We have minus b, which is 5 over 2b, plus minus the square root of b squared, which is 25 over 4b squared, minus 4 times 1 times minus 3 over 2b squared. 5 over 2b plus minus the square root of 25 over 4b squared minus 4 times minus 3, that's plus 12 over 2b squared. Now, okay, sorry, divided, that was divided by 2a. This is divided by 2, and this is divided by 2. Hold on. We cannot just add like this, but they have different denominators. So we have to make the denominators equal. The denominator here is 2, but the denominator here is 4. So we multiply here by 2. So we have 24 divided by 4. 25 plus 24, that's 59. And what's the whole number? 25 plus 24 here, that's 39. So you have 39 over 4 this way. Don't forget the square root. Plus minus 5 over 2 divided by 2. This now is something 5 over 2, no, plus minus 7 over 2 divided by 2. That's about 2 plus 7 over. That's about 2 plus 7 over plus 7 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3b. 5 minus 7 is minus 2. Minus 2 divided by 2 is minus 1. Minus 1 divided by 2 is minus 1 over 2b. And this corresponds to option C. This corresponds to option C, minus 1 over minus b over 2. Sorry, the option is minus b over 2. But that's something as minus 1 over 2b. So option C is correct. We have 3b and minus half b. So let's go to the next question. Right, what I'm going to do now, I'm going to use the Almighty formula for people that use Almighty formula. I'm going to use Almighty formula, but I'm going to speed run it. I'm going to speed the video up that part. I just thought I'm going to continue the audio. So you have 5 plus 7, that's 12b, divided by 4, that's 3b. The first part of the option, and you have 5 minus 7b, that is minus 2b, divided by 4, that's minus half b. That is the two part of the solution. So using both quadratic method and complete square method, you will get the same answer. or the guessing method seems too harsh using the IgweMatics method. Okay, option 9, question 9, you have 1 divided by 2x minus 5 plus 5 divided by 2x minus 1 is equal to 2. So how do we solve this? Now to solve this, you just use find the LCM of this, multiply, you get a quadratic equation here, and you get two linear functions here. By the time you move all this left hand side, you can be able to solve this. But I really prefer solving something that will be easier to solve. So what me I did in the example was to find the midpoint of 2x minus 5 and 2x minus 1. And if you watch this, there's a video on my page that is where you have x plus 9 all squared plus x plus 10 all squared plus x plus 11 all squared all the way down to x plus 19 all squared is equal to 11 squared. Let's find the value of x. If you have seen this video, can you find the value of x if you are given x plus 9 all squared plus x plus 10 all squared plus x plus 11 all squared plus x plus 12 all squared plus x plus 13 all squared plus x plus 14 all squared plus x plus 15 all squared plus x plus 16 all squared plus x plus 17 all squared plus x plus 18 all squared plus x plus 19 all squared is equal to 11 squared? Can you solve for x? I believe you can. If you want to try it out, pause this video and we solve it in 3, 2, 1. Let's go. Now that's what I'm going to do here. So you have 2x minus 5 and 2x minus 1. The midpoint here is going to be the sum of this. That's just like finding the mean. That's going to be the midpoint of these two linear functions. Just like finding the mean. So you have this line here, you have another line here. And then find the line that is in the middle of two of them. Just like finding the mean of these two functions. So you have 2x minus 5 plus 2x minus 1. You have 4x minus 6. 4x minus 6 divided by just 2x minus 3. So 2x minus 3 is the line that will be between these two. So if I say let me let another marker. Let a equal to 2x minus 3. If a equals to 2x minus 3, then 1 divided by 2x minus 5 will become a minus 2. And 5 divided by 2x minus 1 will become a plus 2. In this sense now, we have the difference of two squares, which will be easier to expand than all this. The difference of two squares will be a square minus 4, which is easier. So there is the method I'm going to use that I used in solving this question. So the LCM of this now will be a square, yes, a square minus 4. A square minus 4 divided by a minus 2 is just a plus 2 times 1, that's a plus 2. A square minus 4 divided by a plus 2, that's a minus 2 times 5, that's plus 5a minus 10. A plus 5a, that's 6a. 2 times minus 10, that is minus 8, divided by a square minus 4. Okay, by then you multiply both sides by a square minus 4. You don't have a square minus 4 here. You have 2a square minus 8. So you have 2a square minus 8 is equal to 6a minus 8. Minus 8 becomes out minus 8 here. Divide both sides by 2. You have a square is equal to 3a. Move this minus 3a to the other side. You have a square minus 3a is equal to 0. You factorize, you have a times a minus 3 is equal to 0. So a is either equal to 0 or a is equal to 3. So our value of a is either equal to 0 or our value of a is equal to 3. If you put that into this our first identity, we say let a equal to 2x minus 3. You can now find the true value of x. If a is equal to 0, then x is equal to 0 is equal to 2x minus 3. So x is going to be equal to 3 over 2. If we say a is equal to 3, then we have 3 is equal to 2x minus 3 and 6 is equal to 2x. That means x is equal to 3. So our two solutions is x equals to 3 and x equals to 3 over 2. And that corresponds to option D. So the first thing I did was to let a equal to the midpoint of these two functions. Then I found the difference of two squares. I multiplied all through by difference of two squares. I factorized. I found the values of a, that is 0 and plus 3. I used that two values of a to find the values of x. Using that same identity, we said let a equals 2x minus 3. So using that same value, we will now just say, remember that a equals 2x minus 3. Then the value of x is equal to 3 over 2 or 3. And always that is option D. I also said in the last video that in case you don't have solved this pattern, you should put in those options into the question and see which of them will give you equality. The last question for today is question 10, which says which of the following are the roots of minus 2x cubed minus 3x squared plus 29x plus 60. Which of them here are the root of this? Now, to find the root of this, you have to look at the options. Put in those options, that is, you have x equals to minus 3. Put in the value of minus 3 into that polynomial. If you get equal to 0, then that is going to be this is what they call the root of that function. That is, remember your remainder theorem. If x equals to a, if x minus a is the factor of the function, then x equals to a must equal to 0. By that, you put that polynomial. So if you put in x equals to minus 4, which is the first option, option A is minus 4 minus 1 and 5 over 2. So if you put in x equals to 4 minus 5 inside the equation, you have minus 2 times minus 4 power 3, minus 3 times minus 4 all squared, plus 29 times minus 4, plus 60. Minus 2 times minus 4 power 3, that is minus 64. Minus 64 times minus 2, that is plus 128. Minus 4 squared, that is 16. 16 times 3, that is 48. So you have minus 48. 29 times minus 4, I can't do that in my head, so I'm going to do that on the board. 29 times 4, that is 4 times 9, that's 36. 4 times 2, that's 8, 9, 10, 11, 116. So you have minus 116 plus 60. So you have 128 minus 48, that is going to be 80. 80 plus 60, that is 140. 140 minus 116 cannot equal to 0. There's no defined value, but 140 minus 116 cannot equal to 0. That means minus 4 is not a root of this polynomial. And since minus 4 is not a root of this polynomial, we can easily just cancel out every option that has minus 4. So option A is cancelled, option B is cancelled, and option D is cancelled. That leaves us option C. But now I don't want to just pick option C like that, because remember, in these exams, none of the above is here. So what I want to do is to test all the values for that option C. That is, test all the values of option C. The first value here is minus 3. So you put in minus 3 inside that function, you have minus 2 times minus 3 all cubed, minus 3 times minus 3 squared, plus 29 times 3, sorry, minus 3, 29 times minus 3, plus 60. Minus 3 cubed is minus 27. Minus 27 times minus 2, that is 54. Minus 3 squared, that is 20, that is 9. 9 times minus 2, that is minus 29. Minus 27, sorry. 29 times minus 3, that is 29 times 3. 27, 6, 7, 8, that's 8. 87 minus 87 plus 60. 54 minus 27, that's 27, plus 60, that's 87. 87 minus 87 is actually equal to 0. So this checks out that minus 3 is a root of this. So you have minus 3. But remember, you don't just stop with minus 3. You have to test every single one of the options. I'm going to speed run this part. So the video will not be too. I'm going to speed run this part. Okay, after you run you are going to start part up, and you see option C is going completely correct because you have minus 3, minus 5 over 2, and 4 as the complete root of this polynomial. So that brings us to the end of this part of the video. As always, I think I will put the video on my hand. So you should click the video that is going to show my hand right now and move on to the next part of the video, where I will solve question 11 to question 15. Question 11 to question 1, I think 15, yeah, 15.